స్టార్ట్ చేద్దాం సార్, లేదా 2 minutes వెయిట్ చేద్దాం సార్?
చేసేద్దాం, ఇలా వస్తూనే ఉంటారు ఇంకా.
ఓకే,
మన టైం ప్రాబ్లం అవుతుంది.
ఓకే సార్. రికార్డింగ్ క్లౌడ్ కదా. Good morning to you all. Today, on behalf of ACCA Kakinada Center, I welcome you all to today's webinar on planning, design, construction of projects in coastal districts with case studies by Engineer Surya Prakash, Managing Director, Satyavani Projects and Consultants Private Limited. As all we know, constructions in coastal areas must be designed and built to withstand higher loads and more extreme conditions. Because of their exposure to higher loads and extreme conditions, construction in coastal areas will need more attention while planning, design, construction, and maintenance. This webinar definitely helps the participant engineers on various aspects like planning, design, and construction of various civil engineering structures like buildings, bridges, industries, and towers in coastal regions. This webinar also gives the various precautionary measures to be considered while constructing the above structures with case studies. On behalf of ACCA headquarters and Kakinada Center, we thank Engineer Surya Prakash, an eminent consulting engineer, past president of ACCA, mentor and founder of Smart Infest, who is a person striving for better civil engineers in society and their rights. Thank you very much, sir, for accepting to share your experiences in coastal area constructions. With permission of chair, I would like to share our Kakinada Center attachment with Engineer Surya Prakash. I would like to share some pictures, sir.
Yes, sir. Oh, it's a 1-year-old pictures.
Yes, sir. Last year, it's our last year meeting pictures, sir.
Okay. This is the meeting where we founded.
With this meeting, you seeded this center, sir.
Yeah. Really nice.
These are our members, sir. Actually, all are our ACCA present members, sir. మీటింగ్ వచ్చిన వాళ్ళు అందరూ మెంబర్షిప్స్ తీసుకున్నారు సార్ ఆ రోజు.
Yeah. Thank you for sharing great memories.
Yes, sir. Without delay, I will start the welcome address. I welcome ACCA Kakinada Center Chairman Engineer Badam Sundara Garu. Welcome you, sir. Welcome you, sir. I welcome today's speaker, Engineer Surya Prakash, Managing Director, Satyavani Projects and Consultant Private Limited. Welcome you, sir. I welcome all ACCA Managing Committee, members of ACCA Kakinada. Welcome you all the members. I welcome member participants of various centers of ACCA. Welcome you, sir. I welcome the engineer participants, student participants, faculty of engineering colleges and department engineers. Now I am requesting our center chairman, Engineer Badam Sundara Garu, to say a few words about today's webinar and to introduce our today's speaker.
Good morning to all. It's a very great day for me to introduce Engineer Surya Prakash, who is our old student of JNTU Kakinada. Engineer Surya Prakash is an eminent engineer, consultant, and a mentor who has made significant contribution to civil engineering. Engineer Surya Prakash obtained his bachelor's degree in civil engineering from JNTU in 1986. He did his MS in structures in 1990 from IIT Madras. After working for 5 years as design engineer in 1994, he started Messrs. Satyavani Projects and Consultants Private Limited. He is also the founder and mentor of Smart Infra EST, a trust dedicated to the civil engineering to enhance employability and employment. He was president ACCEI 2013 to 2015 and he is founding president of PSI since 2013. Engineer Surya Prakash is a FIE, fellow of Association of Consulting Civil Engineers India, MICI, etc. He authored a book on design and implementation of communication towers. Engineer Surya Prakash was the guest training faculty to CERI, ESCI, and Hyderabad on CAD of transmission line towers. He was the chief resource person for LEAP lecture in 56 topics for Smart Infra EST. The CAD-FED software developed by him won the ACCE CDC Best Software Award in 2007. He was the organizing secretary for WISE 2004. He organized workshops on PEPSCON 2013, 14, 15, A3C2, A3C 2010, MECON 2007, EIA 2003, IS 456 New Vistas Seismic Design of Buildings, IS 1996, ISIS 1999. He was a member of expert committee for categorization of seismic damaged structures. Engineer Surya Prakash is involved in the successful conduct of several international conferences, namely Como Italy 2011, SCWC, Seoul, South Korea, IASS 2012, and Precast 2014, Moscow, and SCWC Singapore. He guided projects for MTech and BTech students of engineering colleges, IITM, JNTUH, NIT Warangal, etc. He was also involved in of engineers. Engineer Surya Prakash had several prestigious projects during the past 3 decades. He undertook include effort buildings, residential hospital, stadiums, transmission line towers, FM, TV, microwave, other towers, providing architecture, engineering, and project management services. The prestigious clients include Ministry of Defense, IIFS, Tech Mahindra, GVK, GMR, BSNL, Idea, Airtel, Tata, Saket, Manjeera, Janapriya, Ashoka, etc. Thank you very much, sir, for accepting to give a lecture to our members. And one more thing I want to highlight here is that the software developed by Engineer Surya Prakash is on design of buildings and structures, which will be highly useful for all of us. And I requested him to give a demo lecture sometime in the next few sessions. One session will be about the software application and its utilization. I request you, sir, please give us a chance to listen about your software, sir. Now I request Engineer Surya Prakash to deliver his lecture.
Thank you, Sundarao garu. Thank you, Dr. Prasad, for kind word towards my introduction. And I welcome all the participants who have taken out time out of Sunday time and joined this webinar today on a very important topic that is planning, design, and construction of projects in coastal districts, in which I'll be sharing the case studies of projects handled by us. So, with the permission of the chair and the organizers, I'll share the content of my presentation on the screen, and I hope it's being recorded.
Got it, sir.
Okay. Is it clear, sir?
Yes, sir.
Yes, sir.
Please.
It's clear, sir.
Yeah.
Yes, sir. Please.
I hope there is no noise in my audio and it's clear.
Very clear, sir. Very clear.
Okay. So, good morning to you all, engineers from various parts of our country. I thank you for joining this important session being organized by ACCI Kakinada Center, with which I have a very close association since its inception. In fact, it was my dream because I studied in Kakinada. I did my bachelor's in Kakinada. I thought there should be an association of consulting civil engineers, and it's an easy way to connect with all the practicing engineers in Kakinada. And I must share my association with Sundarrao Garu, which spans more than 3.5 decades. And when I was studying my engineering, he was a practicing consultant that time, and it was my dream seeing his performance in the Kakinada city to become a consultant like him. And I am here today as a consultant before him. So thank you, sir, for giving me this opportunity. And thank you, Kakinada Center, for giving me this opportunity. So I'll get on to the topic today, that is planning, design, and construction of projects in coastal districts. Because I'm born and brought up from a coastal district, it's been close to my heart to do any projects on the coastal districts. To share that experience, I had the opportunity to do good number of projects and varied type of projects in the coastal districts. So I thought I must share the experience and the challenges that we faced in handling these projects. So with this brief introduction to the topic, today's overview of the topic is introduction to the topic, and briefly I touch upon planning of the projects, and I share the highlights of the projects that we did in coastal districts, and design aspects of architectural, civil structure, MEP, which we do in our company, and construction, like engineering, that is construction engineering, procurement, and construction supervision, quality aspects, and safety aspects of the projects. Briefly, I'll touch upon, don't go deep into the detail. And case studies of projects, I'll share the details of projects handled by our company. And as I said, built environments needs professionals and engineered planning and design and construction. And we should be also thoroughly aware of these statutory provisions like National Building Code and various Indian standards, Bureau of Indian Standards, IS 456 or IS 875, IS 800, and all the 2000 plus codes required for construction, design, planning, and management. And statutory provisions like fire safety and the environmental clearance and all that, also we have to keep in mind while planning the projects. And value the projects with the good engineering. That is, value engineering is very much essential, which I'll be sharing some of the details that we contributed in the projects. And for the life cycle of the project, that means many times the clients come and ask about the cost initially. As consultants, we must always share the life cycle cost of the project rather than the initial cost of the project. The project cost doesn't involve just cost of construction. Even the time taken to do construction also involves the cost. So time taken till completion of the project and life of the service life of the project, and then during the service life, maintenance of the project. So these are all the important aspects we should keep in mind while planning, designing and constructing, and also advising the clients as consultants. So built environment, this is a picture I have taken in San Francisco. I like this view because built environment mixed with the nature, the greenery and all. I would like to see this kind of pictures in coastal districts because it's very important to have the greenery and a clean environment in spite of us doing our own construction and development. So while we do the planning of the projects, what are all the aspects that we have to keep in mind? The concept, basically the location and size of the project. Initially, while we design the concept, we should keep in mind the location and magnitude of the project. And next comes the feasibility. After the concept, we have to also check the feasibility of developing the project. And then comes the investigation, detailed investigation, that is geotechnical investigation, topographic survey, water feasibility, water availability, power availability, waste disposal, and the stormwater disposal or stormwater recycling. So these are all the aspects we have to study even before we start planning the project. Then we have to also understand the statutory requirements like land use, statutory bylaws, road width abutting the project or approach to the project, airport authority, that is when it comes to the height of the structure, pollution control board, and traffic analysis for the project, and fire safety, and RERA. Nowadays, any real estate project has to comply with the RERA regulations. So as engineers and consultants, we should also be aware of the provisions of this RERA, Real Estate Regulatory Authority. Next comes the master plan. We have to advise the clients not to jump into the project. They will come and say, I want to build 5 floors, give me the drawing. So before we jump into that project, we must also do the master plan of the project and do the concept design, check the feasibility, and then advise the client about its feasibility and moving forward. And then we should also, while developing the concept and master plan, we should also keep in mind the construction planning, the time, the cost, the quality assurance or quality plan, and risk assessment. This is a major thing actually. Now the risk assessment of the project's implementation is a major subject nowadays in construction project. So we should also be aware of the risk associated with the project implementation. Next is the projects in coastal districts. What are all the aspects, especially we have to consider while planning the projects in coastal districts? The first and foremost important point is the exposure condition, particularly when we design reinforced concrete structures. As per IS 456, we have the exposure conditions defined. The severe exposure condition, the normal exposure condition, moderate exposure condition, extreme exposure condition. So we have to assess the exposure, the salinity in the atmosphere and temperature variation. And probably if we are designing the structure closer to the sea coast, the humidity and the splashing, seawater splashing also. So we have to keep in mind this exposure condition. And then comes the marine clays. This is the biggest challenge in coastal districts whenever we plan. Normally you encounter marine clays in the coastal areas. What is marine clay? Actually, the marine clay is the soil strata which has the negative SPT values actually. That means you will be, even when you try to fill the ground, the filled up soil, if you fill 2 meters earth, maybe after a week it will become zero again. So it settles very fast. And so the marine clays we have to handle very carefully. You should have the knowledge of marine clays, basic knowledge, and also never hesitate to consult the geotechnical experts for handling these marine clays, whenever we encounter these marine clays, the ground improvement techniques is a very important aspect that we have to consider while planning because you can't start the project without leveling the ground. And sandy soils, this is another top layer, you'll encounter sandy soil. So in sandy soils, you have the dense sands, medium dense sands, and loose sand. So we have to consider carefully by considering the actual soil strata condition in the coastal districts. Next is the salinity. Soil itself will have the salinity, the chlorides and sulfates. So we have to check very carefully, and we have to design the protection to the foundation even. We have to have the protective barrier to the concrete in spite of giving the adequate cover based on the exposure condition. We have to also give a protective layer to the sometimes like box type waterproofing or waterproofing itself. Next is the groundwater table. I have encountered in most of the coastal projects, because we are close to the sea, MSL level will be 2 meters and sometimes even minus 1 meter also. So I have handled a project in deep water port in Kakinada only, where the ground level was minus 0.5 compared to MSL, mean sea level. So we have to keep in mind while designing the foundation, what type of foundation we have to go for when we encounter this groundwater table. And next is the flooding. This is another very, very important aspect which I'll share in one of my projects where I encountered or I have foreseen the flooding because the client wanted, it was a sloping ground, very nice sloping, natural slope was there, but the client wanted it to be leveled, cut by cutting. So when you particularly cut and level the ground, there will be issue of flooding. So we have to foresee that and plan the drainage, stormwater drainage for such sites, which I will be sharing with you. Tsunami is a phenomenon which we have been coming across in the last 2 decades, 2.5 decades, since 96, if I am correct. And so tsunami is another risk factor we have to consider while designing the projects in coastal district, particularly East Coast. East Coast is prone to this tsunami phenomenon. And the cyclones. Every year, the East Coast experiences at least 2-3 cyclones, and now it is increasing also. Storm surge, like we had in Machilipatnam district, that is in 1970s, mid-70s, if I am correct. So there was a big storm surge actually. So whenever we design the projects in coastal district, the storm surge also we have to study, and ground improvement is a compulsory thing we have to consider for economical foundation and effective foundation design. Dewatering systems. So we must all be aware that when we handle the projects on sea coast where we have the a shallow level groundwater, so we have to do the dewatering. So normally the practice that is available in coastal districts is a suction ring main, suction buffer we call. So we put the bore wells up to 2-3 meters depth, and around the building we prepare a ring main, and then we suck the water. And we have done in one of the projects maintain dry condition where the water level is 0.5 meter above the natural ground. We maintained the dry condition at 2 meters below the ground level by doing this dewatering system. It is I'm sure in Kakinada it is available, many vendors are available. Like that, any coastal places we can think of this dewatering. Next effective foundation system is piling actually. We can also use the precast spun concrete piles which we have used in Ongole, and in Kakinada near Reliance also is using a lot of precast driven piles, not board cast in situ piles. And so piling is one of the important systems that we have to have the knowledge of the vendors and the design systems. And design of windows. This is another aspect. If you all are aware, in Vizag, when there was Hudhud recently, about 5 years back. So most of the buildings are affected because of the windows failing actually. Because normally people think that windows don't require design. So windows also require design, So we have to test the windows, or we have to check the windows for wind effects on the design, whether it is hinges or the glass panes or the closing. Because we designed the building for a closed condition, so the openings, percentage of openings has bearing on the wind pressure coefficient, what we consider. But if we don't design these windows properly, if the windows fail, the openings will increase actually in the building. And so I have come across many buildings failing because of this windows not being designed properly. Next is the sheet piles is another method. In Mumbai, it is very widely used. Actually, you can use the sheet piles to cut off the water ingress into the construction area. Sheet piles or touch piles is another. In Vijayawada and even in many project sites, we have used these touch piles. Next is the jettying, jetty piles. That is, we use a water jet to drive the piles. When you have to do the piling within the sea coast. So jetting is the method which I have used about 27 years back in one of the projects in Tupilpalam, Gudur districts. And the corrosion is another major issue if we don't take care of these exposure conditions and treatment of the steel structures, particularly painting. Most of us do a mistake about this application of primer and protective coating. As per code, when we apply the primer to any steel structure or any even concrete surface or cement surface, we have to apply the first coat of protective coat within 24 hours. Because the primer objective of applying primer is to neutralize any surface that is exposed to atmosphere. If you don't apply protective coating immediately within 24 hours, the neutralized surface will not be neutral actually. It will again become basic or acidic. So it's very important aspect to specify painting of first coat within 24 hours of applying the primer. Next is the ring bunds. That is when we do offshore structures or structures within the backwaters, which we have done in Bhairavapalam. We use the earth ring bunds for the sake of foundation actually. And rainfall data of the rainfall and the season in which you are working is also very important. And particularly narrow front wind. IS 875 Part 3, 2015 has introduced this clause of narrow front wind and coastal wind actually. So which I'll be sharing as we move forward. So when we specify the design parameter, so we have to keep in mind all these aspects. So this is what we are talking about, the coastal zones. This is the east coast, as you see, which has got 180 kilometers per hour or 50 meters per second wind speed design, basic wind speed actually. And in Gujarat also you can see, this is the west coast. Gujarat has the highest wind, again, which is 180 kilometers per hour or 50 meters per second. Rest of it all is less than this, except for the Ladakh, Leh Ladakh region and northeast region, Meghalaya and all that, where we have 55 meters per second or 200 kilometers per hour. And we have seen in the recent 2-3 decades of time, the wind speeds exceeding 180 in these coastal regions. That's why IS 875 has factored in the increase in this wind speeds, that is actually narrow front wind, frontal wind it is called. So let us look at the codal provision corresponding to this. So whenever we design any project within 60 kilometers width from the coast, we have to treat separately for all these provisions that I am explaining. So 60 kilometers distance, with Google you can always locate and check the distance from the nearest coast. And if you are falling within that, you have to take care of this factor K4, that is for the cyclonic wind effects. We have to consider. Importance factor for cyclonic region is the K4, and the east coast of India is relatively more vulnerable of severe cyclones, as we are aware. And on west coast, Gujarat is vulnerable to severe cyclone. So, for all industrial structures, that we design in these coastal areas, we have to consider a factor of 1.15 K4. That means the basic wind speed itself, we have to increase with this 1.14. So the design wind pressure will be calculated based on this basic wind speed or design wind speed. And then structures of post-cyclone importance, like cyclone shelters, hospitals, schools, communication towers, which are very important for hazard mitigation or management, disaster management. It's very important to design these structures with a K4 of 1.3. So let's remember, when we draft the design basis for structures in this coastal region, we have to consider this factor. Next section that we are talking about is the planning. So whenever we plan the projects, we have to identify the site location and approach to the site location from the nearest highway to check the lead and the time taken for transportation and all these things. Next is the site access constraints. Sometimes we even don't have culverts that are designed for the trailer loads that we may have to carry the materials to the site. So it's very important to understand the access to the site before planning and before drafting the design basis. Next is the investigation. We have to plan the stages of investigation. The preliminary stage is information issues to check, investigation of soil, geotechnical, borrow pits, and backhoe pits also, actually. We do this to understand the site in the preliminary investigation, and sites for disposal of surplus earth, and topographic survey. I mean, people sorry, somebody is by mistake, I think, sharing the content. Please remove the permission to others to share content so that we will not be disturbed. I'll start.
Sir, please continue, sir.
Yeah, I'll start. Do you have my PPT or should I share now?
Sir, please share, sir.
Oh, I have to share. Okay. Thank you. So I request you to cancel permission to others for sharing. Otherwise, maybe we'll be disturbed.
Yes, sir. Already done, sir.
Thank you. Thank you. And geological studies. This is very, very important aspect. We have seen for all important projects like power plants and all, we have to study the geological history of the site. So we have geological experts who will study the geological history of the site. We all know Koina Dam story, where it was built on Koina fault, actually, geological fault, and it has resulted in the earthquake. So similarly, environmental investigation, wind roses, climatic conditions by meteorological data. Next important thing is the raw material source, like quarries, lead from the quarry, available vendors or availability of vendors near the site. We have to study all this, and nearest railhead. That is another important thing, because anything like cement, steel, we have to transport. Normally, we'll be transporting by rail, and then from the nearest railhead, we carry all the important material. Next is the R&R studies for large projects, which we also had the opportunity to work on, rehabilitation and relocation of the people or villages when we are building the large projects. So this is a typical climatic condition data, month-wise cold season, definition hot season, southwest monsoon season, and post-monsoon season. So we have to have the wind roses like this to understand the direction of the wind. It will help us in planning the structures very effectively. Next is the sampling of the soils. We must insist on proper investigation. Particularly, I have seen some of the soil reports. At a half meter, they encounter refusal strata and leave it to investigation there. We have to have, if it is a hard strata also, for important structures, we have to collect these core samples and have the RQD value, rock quality designation. So it will give us the idea of one is the costing of rock cutting and the method of rock cutting, and also the soil bearing. And the next calculation of the bearing capacity in hard soils also a very important factor. I have come across people using very high factors of safety in estimating the bearing capacity for the rock sample. The method of rock estimating bearing capacity in rock is to do the crushing strength, and from the crushing strength apply the factor of safety, and then over that you apply the further factor of safety for the bearing, actually safe bearing. Ultimate bearing, one factor, and then safe bearing, another factor. So, so time constraints, topography, cost factors, reason for sampling, we have to decide the sampling very carefully, and there are no specific guidelines given in the IS code, but as engineers, we have to plan investigation depending on the requirements of the project and core recovery of the hard rock. So this is a typical master layout. You can see this is the proposed areas, and this is the proposed areas in Kudankulam. Actually, we had the opportunity to participate in the design competition, and this is the master plan we did. So master layout is very important, and then a detailed layout, concept design with each area with the traffic and parking, greenery, and other amenities, utilities we have to consider while planning the layout. Next is the street network and circulation is also part of the master planning, which we do. And so the primary roads, secondary roads, and tertiary residential streets, we have to plan for the traffic circulation. Next comes the building circulation. So this is the units access. You can see this is the shortest path to reach the each apartment. So we have planned and shown this access, how fast it is, and with the lesser area of the lobby, we can access the units very fast. And similarly, within the unit, what is the circulation area? And so effective area versus circulation area. So these are all the calculations. We have percentage of circulation is 31%. Here you can see flat circulation. Apart from carpet area versus plinth area versus common area, super built-up area, and carpet area versus circulation area. So these are all very important in planning. So we must consider these aspects while doing the plan. So design views, actually it gives us the idea of in Seacoast, this is the planning done in Seacoast, that's why I'm showing. We thought that every unit, dwelling unit should have the view of the sea. That's how we planned. And so coming to the design, architectural, structural, civil and structural and MEP, functional requirement document, FRD, which considers design intent of the client, that is requirements are defined in this document. And based on that, we prepare the design brief, whether it is finishes, facade, or functional requirements like toilets or area allocation, all that is defined here in the planning. Based on that, we do the design development and coordination and bylaw standards and codes and the space, material specification, finish, utility areas, and facade, external services like amenities, landscaping, parking, entry gates, driveways. So these are all the things we have to consider in the planning. And detailing, quantity survey, costing, and the product specifications. Vendors also we have to consider in the design stage itself. And the financial, technical, and tender approval for procurement before going to the construction stage. So next is the construction engineering, procurement like contract packaging, site enabling, method statements for execution. I always say that we should never leave the method of execution to the engineers on site. The contractor planning engineer should prepare the method statement for each activity, whether it is excavation, marking on site, or PCC, waterproofing, all activities we must prepare the method statement and get the approval from the consultant. This we have implemented in projects where there is no misunderstanding of the drawing and the method of execution. And stage passing, this is part of the project supervision, construction supervision, where every stage there should be stage passing done by engineer in charge on the site. Next is the quality, registers: quality plan, quality assurance, quality control, quality audit, quality vigilance, acceptance tests, and quality registers finally. So we must record the quality process in every stage, and the registers should give the complete data of the whether it is cement consumption, steel usage, any material used at the site, chemicals and all. We must create the record, which we have been doing for more than 2.5 decades in all the projects, and it helps engineers doing this actually. Safety, statutory compliance, occupancy certificate, and handing over. So these are all the steps that are very important. So now getting into the core topic of today, that is projects in coastal districts done by our company, case studies where I'll explain the contribution that we have done for various projects in coastal projects, so that it will help you to consider these aspects while planning projects in coastal districts. So I'll share the highlights. We are used to reading headlines in the newspaper, so same way I have put the highlights of each project so that when we go to that project, I'll share those details. So PalmTech is a project we did in Pedapuram, which is about 50 acres of land, which is sloping towards the highway, and the client wanted to have the leveled ground, and we have foreseen that flooding will be an issue because the project is commenced in the month of July, and we all know July is a month with maximum rainfall in East Godavari particularly, and so we have planned the stormwater drain, and the client was joking on me in a lighter vein that you are doing irrigation project instead of industrial project. I said, sir, this is very important because we had a very stiff timeline of 9 months completion for that project, and project was inaugurated. We did the foundation stone and all in July, and it so happened that July month had the highest rainfall of 100 years. So fortunately, because we have considered and constructed the stormwater drainage before commencing excavation itself, so my client has sent me a photograph of that drain with full water, and said, good you have foreseen this situation. Otherwise, our project would have come to a halt. Imagine 50 acres filling with water, and dewatering if you have to do, you could never complete the project. And thankfully, we could complete that project 6 days ahead of schedule in 9 months, in spite of the heavy rainfall. And there, it really, the stormwater drainage really helped. So it's one of the important things I did in about mid-90s, I think, or late 90s in Kakinada. So that's one project which I'll be sharing. And next is the transmission line tower failure during stringing on rollers. It's a very, very interesting phenomena. We did a case study. In fact, you know, the transmission tower conductor, we put on a rollers on the tower before we tension and pull the conductors and tension it. So what happened was that day evening, they have put the conductor on the rollers and left for the day evening. And it so happened on the same day evening, please, I decline and no annotations, please don't ask me for annotations because I'll be disturbed. We will have a question and answer session once I complete my presentation, definitely. Please bear with me, don't send requests for annotation. So what happened was that day evening, 7 o'clock, there was a heavy storm, gale storm. Somebody is disturbing. Please put on mute, please. Oppo.
Yes, sir. Done, sir.
Oppo 812. Yeah, thank you. Please keep on mute, otherwise everybody will be disturbed unnecessarily. It may not be by intention, but by accident. But check all your screens for mute. And then, so what happened was the wingspan of that structure has gone 5-fold, because when the conductor is on roller, when there is a wind, the wind span will change. In fact, because of that, tower failed during erection itself. So there was an investigation, and I could find this interesting phenomena during that. So coastal areas, when we plan from then on, we specify during erection, please clamp the conductor without, never leave the conductor on roller when you are leaving the site. So that's a very important thing. Next is the tower foundation in Kakinada only, 90 meters tower in Cinema Street, I think. Yeah, we close to Cinema Street. We have done a 90 meters tower for Idea Cellular. Those days, we estimated some 20 piles requirement for that tower foundation. And the client came back to me saying that just executing 20 piles is not viable for us. Cost is going up. Why don't we design the raft? But then water table was at 2 meters level from the ground level. And so we have done the dewatering system there and successfully executed the raft, which I'll be sharing those details. Next is the industry we did in deep water port in Kakinada, Arani Agro Oil Industries, now Agrawal Industries. So there also, client wanted to go for pile foundations there. But when I reviewed the soil report of that site, I found that up to 6 meters depth, there is a good strata. And beyond 6 meters, it is a marine clays. So if normally we go for pile foundations when you have the hard strata at a deeper depth. But here in this case, the marine clay is there up to 30 meters depth from 6 meters. So it is never economical to go for pile foundation in such a case because the industrial sheds, the loading is less compared to normal building. So I suggested to the client that we'll go for open foundation with the dewatering system. And I have shown the calculation value engineering report where I was saving 20 lakh rupees apart from saving the time because we could complete the entire foundation system within a month's time by maintaining 24 hours dewatering for that site. In fact, unfortunately, I couldn't locate that photograph because it is more than 20 years old. But we could maintain the dry condition for a whole month and completed the foundation. And client was happy because we saved the cost and time. Next is the Vizag cyclone Hudwood affected industrial building. Roof is blown off. Very surprising incident in Vizag, a structure designed by us. When we investigated, we found that the anchor fasteners, self-tapping screws we use for the roof sheet. Even Vizag airport roof was blown off during Hudwood. So it's very important to specify the anchor fasteners and test these anchor fasteners. The washer that we use and the tightness we have to use very carefully and specify and check particularly hilti fasteners with neoprene washers. We have to use the neoprene washers, not the rubber washer. Because the cost difference between neoprene and rubber washer is too much. Contractors tend to go for rubber washers. So we have to check these washers also. Because rubber washer will get decayed with water exposure, and whereas neoprene is a material that will stay for long. So it's always better to use the neoprene washers. That is very important. Next is the power distribution poles. We were consultants for Government of Andhra Pradesh for hazard mitigation and cyclone recovery, emergency cyclone recovery project. I'll share some of the photograph where the distribution poles you see, normally they'll put it along the roads and canals, East Godavari particularly. So those poles will be inclined. So normally these poles foundation is not designed properly. We have to design as a stem foundation. That means we have to use the shear modulus of the soil for design of this pole foundation. Next is the plinth level for the towers in paddy fields. This is another thing we observed. Most of the towers had corrosion in the bottom stub portion right above the plinth level, because the plinth level they used to follow 230 mm, 9 inches above the ground level. In paddy fields, if you see the watering they do, the water itself will be about 1 foot. And imagine if there is a rainy season, the water level will rise, and because of the exposure condition, there will be extensive corrosion in the leg, which is important. And so we have specified increase in the plinth height. Next project we did is in Cochin, IQIP. There is a marine clay, and we started the ground leveling, and it used to sink. And so we have used these porous vertical drains so that you take out the water as you fill the soil, so that you'll be. So this is a ground improvement technique which we adopted, which I also I'll share. And tower retrofitting for revised wind loading. In transmission towers in coastal region, because of the increase in wind, we have seen the cyclonic wind and factor of K4. So you have to retrofit the towers. So we have done the retrofitting of these towers. So every 5 years, as a rule, all our structural engineers should tell the client that any certificate, stability certificate that we issue for the structure is valid only for 5 years. Beyond 5 years, you have to again revalidate as per the codes if there are any revisions, or the loading or the exposure condition or the maintenance that is being adopted is adequate or not. We have to verify and certify for another 5 years. So every 5 years, we have to revalidate the structural stability with the current codal provisions and the loading and maintenance condition. Next is the RCC building corrosion. So this also I'll share the photograph of how extensive corrosion it can happen in coastal region if you don't provide adequate cover considering the proper exposure condition. Next, we have done the aqueduct jetty files for 70 meters into the sea. We executed an aqueduct. There we had the pumps, submersible pumps, which pump the water, seawater into the jetty aqueduct, and we take it into the reservoir, raw water reservoir. So that also I'll share the photographs. And bridge pile foundation failure in marine clays. This happened in East Godavari only for us because the soil report was not properly done to the adequate depth. So pile foundation was executed and terminated in the marine clay level, which was not brought to the notice of the consulting engineer. And so the piles have failed and the bridge has collapsed. So this also we have to keep in mind. Detailed investigation in particularly marine clays, you must specify investigation up to the hard strata, and if you are going for pile foundation or well foundation, you must rest these piles of well on the hard strata only by anchoring it as per the provision. If it is a soft rock, you must have 2 meters anchorage. If it is a hard rock, at least 1 meter anchorage of the piles. So this is very important. And earth ring bunds for well foundation in backwaters, and then roof sheeting anchorage, as I said, clamps, screws. Nowadays we are having the standing seam, seamless roofs. There we use the clamps, so we must check and inspect very carefully these clamps, or if we are using screws and washers, as I said, we must check these screws and washers. Expansive swelling soils, proper design of piles, or treat the foundation soil. That's very important. No saline water to be used in construction. So check the water quality in coastal districts. And you have to give provision if required to treat the water, saline water, or to remove the salinity in the soil. And mostly we use the sulfate-resistant cements in the coastal regions. And in the very first project in '94 itself, we have used the sulfate-resistant cement. Seashore sand not to be used, that is very important. And many people tend to use the pit sand, which is also not good. We have to have the sand conforming to gradation specified in IS 456. And the scouring, this is another important phenomenon. In sea coast, you will have the scouring of the soils, erosion, soil erosion due to the wind. So we have to consider these aspects. And uplift anchorage at every stage of load transfer and side thrust. So this is very, very important because the buildings, industrial buildings particularly, there will be uplift in the structure. So we have to check the anchorage, uprooting tests we have to do, and checking we have to do for the foundation and for the structure also at every, because cyclonic winds will lift the structures. So we have to have the checking of uplift anchorage at every stage. So now I'll be sharing the photographs of the projects. So this is a flyover rotary management system we are doing in Vizag, which is nearing completion almost. And so we have completed the design and execution is in progress. So this is the NAD junction rotary management system with the precast eye girders. So this is the design we did. And this is in Srikakulam. We are doing a township for which DPR has been approved. 350 crore project of township with 2,000 houses. So this is on the sea coast, and there we have planned a fishing harbor kind thing for the fishermen who are going to live here. So this is another project, and these are some of the views of this project. So while planning, we considered all these. Next is the Balasore. We have done about 60-acre project. It's a master plan with the villas, a school, and a star hotel with convention center, which was planned by us. And this is also executed by the client. And Vizag, we have done the Tech Mahindra, wherein we had the problem during Hudhud for the windows because of the improper execution of the windows. So we had to retrofit those windows after the Hudhud cyclone. So these are the views, and this is Kodunkulam, where we won the design competition, but our concepts were assessed, given the best rating, but unfortunately we didn't do. And this is the corrosion problem in Calcutta. I was telling you, RCC, you can see the reinforcement in the concrete structure because of the improper cover, inadequate cover. You can see the steel in the slabs and beams corroded extensively. In fact, we rejected this structure. You can see this corrosion stirrups and the main bars in the beam due to the corrosion. And this is the column. You can see ties, column ties, and the main bars. You can see you don't have to do the proformator. Please don't send me annotation request. I'll take questions toward the end of my talk. So this is another edible oil factory we did in Kakinada, near Kakinada. So this is also completed project. So this is a steel and composite structure we have done, and it is recently last year completed, I think. So this is the pictures of completion. And this is a 4-point Sheraton Hotel in Vizag, which is managed by us, and APNJ, we have done the. And this is a Chirala ITC on the coast. Very interesting structure. We did complete steel, and I had the opportunity to visit the structure after 20 years, and I found not much of corrosion because of the good maintenance and good painting that was adopted those days. And this is the photograph of the structure. You can see the water table just below 2 meters, and it is all sandy soil. This is a naval dockyard structure, office structure we have done in Vizag, which is Griha rating targeted. And this is a palm oil mill project in Pedapuram near Kakinada. This is where I said we had this stormwater drains. You can see. So this is the layout of the project. We have 50 acres. So we have done this stormwater drains before even commencement of the work. And this whole area was excavated to make a level ground. So for that, this stormwater drain, you can see this stormwater drain here. During construction, this drain, a 3-meter width and 3-meter depth drain was executed, and it worked perfectly. And in Vizag, we did the gas turbine project for the HPCL through BHEL. And so you can see we have used the protective coating to the rebar in the foundations and structure. So it helps in reducing the corrosion that what we have seen before, protective coatings. But implementation, again, here we have to see that the painting is done adequately. So this is the HPCL power plant. And next we did the balance of plant works for the Gautami Power. Now it is called Reliance Power. So we have done that, and this is the RNA Agrotech which we have done in Deepwater Port in Kakinada. So this is the layout of the project, which is on the sea coast, and ground level was half meter below the sea level, mean sea level. So here for this entire plant area, we have done the dewatering system and maintained dry condition at 2-meter depth in spite of water table being above the ground, and we could successfully complete it. So this is the photographs during construction of this Arni Agro. You can see the ground, it's all moist ground. In spite of that, we could maintain the dry condition and completed the project on time. And these are the water treatment plants, sewage treatment plants in Salem and 6 other districts in Tamil Nadu, which we have done about more than 100 crore project. We did it for Tata Projects EPC project, as EPC consultant. And this is another resort which we did the proposal in near Chirala. So this is the concept we have given to see that every room will get the view of the sea. That's how it is planned. And there are other options which we have done, beach resort. And this is a Samalkot power plant, balance of plant works we did. And housing we did in Chennai for defense. This is married accommodation project. These are all the completed photographs of this project in Chennai. This is the married accommodation. And for proposal, again, this we did for Tata Projects recently for Kochi Metro Rail. We have done this concept. See, in the concept itself, we have given this opening so that to reduce the effect of coastal wind. This is the idea we have created. Also, it will break the monotony of the structure in the concept. And this is a bridge we did in the backwaters in Bhairapalam, mainly for cyclone evacuation and AP hazard mitigation. And here we have used the ring bund and well foundation here, kaizens. So this is the photograph of that. And in Nellore, we did again under hazard mitigation bridges for irrigation department. And this is a mall and multiplex in Ongole, where we have done the precast piles, driven piles, not board cast in situ piles. So the driven piles are used here. And because here also we had the water table at 2 meter depth, so we didn't go for open foundation, and we have used the precast spun concrete driven piles. And interim capital of government, Andhra Pradesh. Also, we did the RFP for secretariat. This also comes under coastal area. The structure is designed for 8 floors, but they have executed only 2 floors. And we have used the board cast in situ piles in this project. So this is the photograph of the secretariat. And APIIC headquarters in Mangalagiri also is done by us engineering completed project. And in Guntur, we did the APIIC region zonal office. This is also completed project. And AP TIDCO office also we designed in Vijayawada. And this is the EPDCL headquarter in Vizag. And a Snow Kingdom in Chennai. We did, this is a Snow Kingdom. All these projects we have considered these coastal specifications, whether it is cover, protective coating, or groundwater conditions or salinity in the soil and waters. So this is in Mumbai. Again, we did a Snow Kingdom. Mumbai also comes under coastal region. So we have designed this Snow Kingdom in Mumbai. And this is my alma mater, JNTU Kakinada, where we have designed a multi-purpose auditorium, indoor sports come accommodation come gym and all that for the student. And so this is also designed by us. And we have done a hospital building in Kadepalgudam, which also comes under coastal region in West Godavari. And next, this is what I was talking about, the hazard mitigation for the entire AP state. You can see this pole leaning, because it is standing on the canal side. So most of these poles used to be inclined or swaying. So we have suggested a foundation system using the STEM formula. So so you must have the adequate passive resistance. Otherwise, you have to increase the pedestal size and give the adequate design. So it's very important. So here you can see these are all the poles which are leaning. So we have done the inspection of all these because in cyclone time, particularly these poles will collapse and there will be power outages for a week and all that because of the improper design of this. Though a pole is a small structure, without proper design, it can lead to a lot of difficulties and the disaster management becomes very difficult. Cochin Shipyard, we did this housing for officials. We won the design competition, and this is also executed in Cochin. And Jawaharlal Nehru Port Trust in Mumbai, we were doing the project management for implementation. And also, this is a warehouse of 7 lakh square feet in Vapi, Mumbai, near Mumbai, which also comes under, in fact, it falls in Gujarat border. And so we have done this design, and the single largest warehouse we did is about 7 lakh square feet. So these are the inner views of this Unilever logistic park. And we also did the structural validation of Thiruvananthapuram, Trivandrum, RBI building. We did the structural validation. That's what I keep telling, every 5 years we have to do the validation. And this is the transmission tower I was talking about, collapse during stringing, which happened. So we used the rollers on this conductor for conductor stringing. So when they are left on the conductor stringing without locking, the wingspan was increased threefold, and so the tower collapsed even before it is strung with the conductors. So we have to be very careful while specifying the safety during construction specification for this transmission tower. So this is the 90-meter tower I was talking about in Kakinada, near this for Idea Cellular. So it's a tower designed by us, and the foundation in Kakinada, because we had to convert from pile foundation to raft foundation, which was successfully executed. So this is the foundation in a sandy soil, which was done. And this is the drawing for a raft, annular raft. With the concept of annular raft, we did the tower foundation as a raft foundation. This is the palm oil mill I was talking about, which we completed 6 days ahead of schedule. So you can see the stormwater drain here. So this also, and these are the oil farm. So oil farms is an interesting foundation we always design with a hook tension. The force transfer is by hook tension because the bearing is not critical here because it's an oil. So ultimately we transfer the load by hook tension. So here we just make a ring beam, fill it with sand, and on the sand we put the bitumen carpet and erect this steel structure, because the whole load transfer is by hook tension, because weight of oil is less compared to water even, and so the bearing is never a critical thing. So very interesting design. This is the aqueduct I am talking about in Gudur, near Gudur in Nellore district. So this is our first project done by our company, 1.2 kilometer long aqueduct with seawater intake. You can imagine the cover aspects and the protective coatings and water barriers and expansion joint treatment in this was all challenging. So we have successfully done it. And so these are the photographs during execution about 27 years back. So this is a flyover over the aqueduct, and we have designed the aqueduct with adequate cover. The latest we did was last year during the lockdown period. We did the review of the DPRs for the fishing harbors in 4 locations in Andhra Pradesh. So this is Uppada near Kakinada. So this is the fishing harbor, and this is the breakwaters. So we have done the DPR validation and submitted. And another fishing harbor is in Nizampatnam, and another fishing harbor is in Machilipatnam, and last one is Juvaldini. So these are all the 4 fishing harbors for which we did the review of the DPR and submitted. So this is the proposed outlay plan for Juvaldini fishing harbor. You can see we have overlaid on the Google to check the backwaters and breakwaters, and then we have introduced the chemical attack and bad concrete. So marine structures, wave effects, and leaching action and differential condition. So we proposed this precast, spun precast pile in that project for all the backwaters and foundations for the structures. So these are factory-made piles, so they will have very good resistance, and the grade of concrete that we can achieve with the normal mixed design is M80 grade because of the spinning that we do. And this is the method of preparation of this spun concrete. I'm associated with the factory for last 35 years, and I proposed them to go for this spun tiles. Now they have the factories in Vijayanagaram, Narsarapet, and Hyderabad also. So this is the pre-stressing and spinning and then steam curing here. So these are all the stages of casting, and load test is done on the pile and transported on this. And you can drive the piles in hours time. And so you can have the ready to erect piles capacity of 280 tons, up to 280 tons. And we also proposed a hollow core for jetty instead of conventional concrete, because precast hollow core we can erect fast and do the street concrete on top. This is for the jetties and quays. And breakwaters also, alternative breakwaters are proposed with the geotubes we have used to reduce the filling and time-consuming aspect of the filling for these breakwaters. So this is the main presentation from my side. Now I am ready to take questions. I request the organizers to pull out any questions from the participants. Thank you.
Thank you, sir. Thank you for your valuable presentation.
Yeah.
I request the participant to ask their questions.
Yeah, now you can unmute and ask any questions from your side.
Sir, I have one question.
Yeah.
I think in R&D projects, you told that instead of pile foundations, we have gone for raft foundations. Is it safe from liquefaction effect?
Liquefaction is a different phenomenon. If you are having in the top layer with a silty sand type of soils, then we can treat the soil for liquefaction, sir. We have used the geotextiles to handle this liquefaction. 10K is a company which we have used. We have strengthened the soil with this geotextile, and we have designed to resist against this liquefaction. Ground improvement we did.
Do you suggest geogrids or geomembranes, geogrids for buildings soil stabilization?
No, not slope stabilization. Geogrids and are good, sir. Actually, slope stabilization. For building bearing foundations, either you should go for stone columns or screw piles, or we must go for soil improvement with this cement stabilization kind of.
Or densification.
Yes, densification.
Densification, yes. But is somebody recently for one residential building, some structural engineer has suggested this geogrids. I told that those are not yet proven for the buildings. For roads and for slope stabilization, they are okay.
Correct.
But for buildings, till now, it is not recommended. That's what I told them.
Yes, sir. You are correct, sir. Absolutely right.
Yes, yes.
Any other questions?
Sir, in one of your picture, we found the corrosion resistant paint for reinforcement, sir.
Yeah.
What are the precautionary measures to be taken while bending and placing the reinforcement, sir?
Actually, you must apply the protective coating before just placing, actually. And you must do the second coat after placing, because while placing also surface could be damaged. After cutting and bending only, we must apply the protective coating. In Mumbai, I came across a company who will do the galvanizing even, the V-bar, and they supply the galvanized bent up bars. So that is the best if you can use it. It will cost about 6,000 rupees per ton extra.
No.
Sir, is it recommended for the regular residential buildings, sir?
This corrosion resistance, huh?
Corrosion resistant.
Yeah. In fact, for smaller buildings, it is much better. But engineered supervision is very essential. Check to see that there is no damage done. And in spite of doing corrosion resistant paint, better give the cover, excess cover from the normal cover, actually.
Cover should be more for protective coating.
No. In coastal areas, we should not follow the moderate exposure. We should use the severe exposure or extreme exposure conditions in IS 456 and adopt the cover suggested for that.
Okay. Sir, how do you advise wind stabilization for residential buildings in expansive soil, sir?
Yeah, good question. Actually, in expansive soils for residential buildings, it is better to go for undering pile if you have the definite end of clay strata at 5 meters or 6 meter level, and if you have the good strata beyond 5-6 meter, go for undering piles. Otherwise, you can. I have done in Nizamabad, not in coastal district. We have given a riprap actually. Foundation in clay soil, riprap. That means it is my proposal actually, which was accepted and it is working well. The problem with expansive soils is swelling pressure, and the swelling pressure is directly proportionate to the volume of mass of the clay strata actually. So if we can cut this clay strata, you cut the clay strata with this ring beam, edge beam, like deep beam, and then provide the deep beam will help in preventing differential settlement and also reducing the water ingress. There are two aspects of handling expansive soil. Mainly reduce the variation in the saturation conditions. That means exposure to water. So ensure proper drainage around the structure. So then you don't have expansion and contraction. And next is reduce the mass of the clay. So these are the two solutions for smaller projects, particularly where it is difficult to use a lot of technology. Just go for excavation, cut a trench, ensure a proper drainage, and then provide a deep beam on the outer periphery of the building. That will solve the problem of the uplift and expansion.
Deep beam means how deep, sir? How deep you suggest?
1 meter. Normally, you in residential building 450 or 350 depth beam is enough. But to make it 1 meter deep and so that it becomes a rigid foundation. So you can avoid the differential settlements.
For smaller sites and small buildings, it may not be possible to go for pile foundation also, sir.
That's why I'm suggesting deep beam.
There, this is the best procedure.
Yeah, I have used it.
Yes, sir. Yes, sir. Recently, we did line stabilization for one building.
Yeah.
And riprap for the footings.
That's a good solution. In fact, lime stabilization also is a good solution.
Substantially increases the SBC.
That's right.
But for sandy soils, land stabilization would work out, sir.
Yeah. Bentonite also.
Yeah.
Sir,
Sandy,
please continue, sir.
thank you, sir.
Okay.
Sir, there is a question from Subramanyam Avala. Which is better, corrosion resistant steel or epoxy coated steel?
I always suggest epoxy coating as compared to corrosion resistance steel. Corrosion resistance, yeah, that's good, but again, it's not 100% foolproof. Corrosion resistant steel. It will reduce the extent of corrosion, but not totally. But protective coating, we can check thoroughly and use it. So I recommend protective coating.
Hello.
Yes.
Hello,
Sir.
sir.
Yeah.
Am I audible?
Yeah.
Yes. Sir, I am ME first year student.
Louder, please. Your voice is feeble.
Okay. Sir, I am ME first year student.
Ah.
How should I go for designing and all? How to make career in this?
Yeah.
So new to this field, so I'm not able to.
You are in the first year MTech, no?
Yes, sir,
Kapil?
MTech.
Yeah. So my first suggestion is, if your institute allows a 1-year project outside your campus, go as an intern into a company. I have recently done many students like that, and they are benefited. In fact, not even now. About he is not in contact with me after that. He is very well settled. So for MTech students particularly, it's always good to go to companies as intern to do the main project. That will help a lot.
So which type of company should I approach?
Design companies,
Design company.
consultants.
Yes. Thank you, sir.
I am Srikanth here.
Hi Srikanth, how are you?
One small query.
Yeah.
Hi.
Yeah, please.
Thanks to our Kakinada Center for making us to listen to you regarding this coastal problems.
Yeah.
Because I am actually in marine structures specialized MTech.
Oh, great.
Yeah, so I was, but unfortunately I could not listen totally because some of the guests were there in my house. So half of the lecture only I could able to listen.
Okay.
But still it was great, because the experience makes much more than what we learned in our colleges.
Yeah, correct.
So you are into that, and I was really enlightened by again listening all your experiences and your solutions for the some specific problems and all that. So thanks a lot, and I have one small this thing request to you. We are missing you on every Sunday. We used to love to talk to you, and we are really missing it. So
Yeah, this Sunday anyway we started, so let us continue every Sunday.
Yeah. I want one or the other way. We should keep meeting, not necessarily this way or that way, but we should always be in touch. That is what I feel we are missing it nowadays.
Yeah.
So please think in that line, and always we want to be nearer to you.
Yeah, sure.
Yeah, thank you.
We'll start working on it, sir. Thank you.
Thank you.
Good morning, sir.
Yeah, Raghu?
Yes, sir. Good morning.
Yeah.
Sir, I have a question. I have read some articles regarding bamboo reinforcement being used in concrete.
Yeah.
How far it is being used in the infrastructure projects, sir? I mean, is it really viable, or is it still under research stage? Or
yeah, it is still under research actually.
are there any codes regarding this bamboo reinforcement?
Not yet.
No. Okay. Because do you
think
this bamboo reinforcement will be more useful in this coastal region projects?
Definitely, yes. But it requires a lot of research and development of the standards for utilizing this. So before we engineers specify such things, we should be very careful because in social media I have seen people were sharing and excited about it, but I'm not excited still. I have to see the real data through standards and provisions before I start using it.
Fine. Okay. Thank you, sir.
Okay. Anyway, good question, Raghu. Yeah. Any other questions?
Sir, Mr. Farhan posted, explain about the dewatering process of foundation.
Yeah, that's a good thing. In fact, what we do is, suppose our depth of foundation is 2 meters and water table level is 1 meter or half meter from the ground level. What we do is we put the bores, auger the bores around the structure. We can calculate the permeability of the soil and estimate the discharge from each pit to draw down the water level to 3 meters. For a 2 meter depth foundation, we must draw down the water table to 3 meters. So you can calculate the discharge required to maintain the drawdown condition. So normally for that project I have shown, we have used a 5 HP pump with a 2-inch discharge of the water, and we maintained a 3-inch suction buffer, and we could maintain the dry condition at 2 meter with the 4 meter depth bores, actually augers. So that can be done for us. If you have any specific project query, I can give the solution. I can guide on how it is to be done.
Sir, you told that vacuum dewatering, sir?
No, not vacuum. Vacuum dewatering is a system used for floorings, actually. Olden days. Nowadays, there is no need for vacuum dewatering because industrial floors, particularly where toughness and hardness is important for the floor surface, they used to specify vacuum dewatering because we didn't have the plasticizers and floor hardeners those days. But nowadays we have these plasticizers, super plasticizers, with which we can reduce the water cement ratio. Because for vacuum dewatering, the main purpose is to reduce the water cement ratio. And with the current day, we can design the concrete mix with the 0.3 water cement ratio also, and then apply the hardener on the top. So vacuum dewatering is not required. What I'm telling is dewatering, actually. That is the ring main that we provide around the structure proposed, and we provide the bores up to beyond the depth of the foundation and suck the water from the ground. That's not vacuum dewatering, it is the dewatering, actually.
Okay, sir. Thank you.
If we need dry condition at 3 meters, we should drill the pump at filter point up to 4 meters, right, sir?
No, beyond 5 meters. You draw the, depending on the extent, we draw the, you can draw the drawdown curve for depending on the permeability of the soil. And you can test the water discharge also at that given site. And then decide the depth. Sometimes you may have to go for even 6 meters, 7 meters. Yeah.
Main decision is based on the soil condition, permeability.
Soil condition, water table, and extent of drawdown you have to maintain.
Sir, in expansive soils or impermeable soils, it is very difficult to avoid the water infiltration. No, sir?
No, in clay soils you don't get the water. There you can use the sheet pile. You don't use the dewatering.
Actually, at some places we did one commercial project in Adoni, sir, Kurnool district.
Yeah.
There we gone for that cellar almost 5 feet below the road level.
Yeah.
Then when we are excavating for the foundation, the lot of infiltration is there from the sides. That
because
is a
of
typical
Hungry River.
And the layers are like stone layers like thing. It is not soil like. And
in fact, in such shallow depths, if you are going for basement, no, you can design the drainage instead of dewatering. and you provide a collection pit, you deeper collection pit, and then pump out. Otherwise, you can use the touch piles. If it is deeper, go for touch piles.
Touch
That's
piles.
better. Yeah.
That is a really difficult task, sir, while executing. Totally sheet piling or some net type of this thing?
No, touch pile is easier method actually. Vijayawada, we have done many projects in clay soils also, because Krishna River is there, you know, the water is there, clay is there. So that's why.
Is there
Some photographs I will share with you.
Yeah, please share.
Yeah. And drawing also. We have done 20-meter deep excavation
20
for
meters.
basement. Yeah, for basement with touch piles. That is in Bangalore. And in Hyderabad, we did 22-meter deep excavation without touch piles, but with drainage design.
Oh,
So we have, I have all these examples with me. I can share the details.
please share.
Yeah.
Thank you.
And in both the cases, 1 lakh square feet. The extent of excavation is 1 lakh by 20 meters. So that means about 20,000 cubic meters.
1 lakh square feet.
Yeah.
Floor area.
Yeah, 2 lakh cubic meters of excavation we did. In both the cases.
Really volumetric.
Yeah.
In such volumes, it is possible, sir. Small projects, is it viable, sir, for that?
No, that's what I'm saying. There is no generic solution for any project. That's why we should keep discussing different solutions possible. And for a given project, you do assess which is the value solution. So you suggest, I mentioned in the beginning itself, location, size, and the concept, all three depend on each other actually.
Each solution is unique and tailor-made.
Yeah, that's right. But if you have the idea of all these solutions, you can identify which will fit best for the given problem.
Which technique to be used at what?
Correct.
What problem?
Correct.
Thank you, sir.
Any other questions?
If you have any other questions also.
Yes, sir. One question from Anirudh, sir. We know polymer reinforced based concrete has very high durability and has excellent corrosion resistance.
Yeah.
In spite of this high appreciable feature, why we are not seeing much use of fiber reinforcement in coastal areas?
Actually, yeah, it's a good question, Anil. And actually, I have used polymer like a polypropylene fiber in Hyderabad in one project where I didn't use the reinforcement itself, but it was a composite slab, deck slab with polypropylene reinforced concrete. It's almost like 20 years, more than 20 years old. It is performing perfectly. There is no problem. And coming to the polymer reinforcement of the concrete, it definitely reduces the porosity of the concrete. It is one of the recommended methods to reduce the porosity, because porosity is the main thing for corrosion, main cause of corrosion. So we have to think of the reducing the porosity. That means the density of concrete can be increased with polymer reinforcement. So I definitely recommend you can specify polymer reinforcement in the concretes in coastal districts. It's a good point raised on it. And we have to periodically do the carbonation tests in the cover region particularly to assess the residual life of the residual design life of the structure.
Sir, have you used this geopolymer concrete anywhere in project, sir?
Not yet, but yeah, it is quite possible now. I'm waiting for an opportunity to use it.
And one more question, sir. What about the same foundation retrofitting, sir? What about
Foundation.
the same for
Pardon?
foundation retrofitting?
Yeah, we have done one existing building of 10 floors. We have done the retrofitting of the foundation. We have used the micropiles. So we have successfully executed. It's more than 10 years old now. And in Chennai also, we did one hotel, Taj Hotel retrofitting from 3-star to 5-star. So we did the retrofitting of the open foundation by increasing the extent of the foundation. It is possible. So micropile is the best method to retrofit the foundations. Underpinning is another, we all know in Chennai, not as a consultant, I was working as a design engineer in one firm in Chennai. We did underpinning of normal residential building where there were expensive place and settlements found in the building. I have designed underpinning then. So these are all the retrofitting methods that are possible.
Any more questions, sir? Sir, please share any experience for blast designs, storage buildings, or cubicle structures to store missiles like.
I have done actually. I don't know who has asked. I don't know by knowing
This is
these.
question from Lakshmi Narayana. Lakshmi Narayana, sir.
Okay, okay. In fact, I had the opportunity to design many structures, actually blast resistant. One in two in Hyderabad, one near Delhi. I cannot share the location because they are classified projects. Because these are required in the defense mainly. And Akash missile storage, we have done the design. Blast pens, actually, they are called blast pens. So there are two different types. One is blast pen is designed with a concrete structure filled with sand. So that will be the damping method to resist the blast. Another method we did is using the lattice laced concrete, it is called. You know, lacing. Normally stirrups we provide in the perpendicular directions, and in the concrete we provide the lacings in 3-dimensional direction. So there is a design code given by UK and American defense ministries. So we have used those codes to design nuclear blast resistance also. So we had the opportunity to design. So we have done the laced concrete confined with the MS plates. That is the blast resistance structure. It is a complete enclosed room with robotic arm inside. But the door design, because you need the access inside. Door design is the biggest challenge, and we have done it and got the approval of DRDO also. And another structure we designed was isolating the structure from nuclear attack. So that also we did. 15G is the acceleration, which has to be brought down to 0.6G. 0.6G is the highest earthquake acceleration, and we have to damp the 15G acceleration due to nuclear attack to 0.6G. So that structure also we have done. That is a 3-stage isolation of the structure for shear, bearing, all isolations we did.
Sir, one question from same person, sir. What is your view? Use geopolymer concrete in that?
In the blast resistance, sir?
In that, like, you stopped that question, sir. In that area, sir. Sorry, in that area.
Yeah. Actually, geopolymer is very good in terms of corrosion resistance and durability of the concrete, and also reducing the porosity of the concrete. but I didn't get the opportunity so far to specify it in project so far. I want to use it. I know one Rajmani, who is our ACC member from Chennai, he has done extensive research, and another, our former Secretary General MS Sudarshan also did on this geopolymer. So I have the access to data, so I want to specify in the next opportunity I do. It is definitely useful.
Mr. Rajesh Kumar asking about GGBS cement. GGBS cement.
Yeah. In fact, GGBS, I don't suggest directly using GGBS in important structures, particularly high strength, because it is always better to do the mixed design with the slag separately. For example, our Vizag steel plant slag is used in Burj Khalifa. 60% slag is used, but with proper design. In GGBS, we don't have the control on the constituents actually. So it is difficult to make proper mixed design using the GGBS. So I recommend going for OPC and mix with the slag. Don't go for GGBS directly for structural elements.
Sir, but GGBS is recommended in ready-mix concrete, sir.
That's what I'm saying. Mixed design, you have to be very careful
Mixed design.
in monitoring
Proper
the
mixed design.
proper mixed design and also quality of GGBS.
Quality of GGBS is
Constituents. You know, the cement we think is homogeneous, but there can be a lot of variants in cement, which can lead to a lot of problems if you don't monitor quality of the cement properly.
For high strength cements, GGBS is strongly recommended, sir.
Recommended, but I am saying it requires a lot of validation and monitoring.
Quality control.
Yeah, with the proper care and fineness is the most important aspect for the GGBS.
Yeah.
Fineness. Without fineness, you won't get any strength.
Yeah.
So fineness aspect is also an important aspect for selecting GGBS. Sir, thank you very much, sir.
Yeah.
For your excellent lecture, particularly concentrating on coastal area constructions.
Yeah.
It is very, very useful for all of us, and we are highly thankful to you, sir. Thank you.
Thank you very much.
Now I request Durga Prasad to say a vote of thanks.
Sir, thank you very much, sir. I would like to thank ACCA President Aswath MU, Tamil Salvan, Vice President South, and staff of headquarters of ACCA for their valuable support in this program organization. We are very thankful to today's speaker, Engineer Surya Prakash Garu, for his valuable time. I would like to thank our Center Chairman, Engineer Badam Sundara Garu, Treasurer, Managing Committee members of ACCA Kakinada for their valuable support. I would like to thank all the engineer participants and other participants. I would like to thank Mr. Sunit, member of ACCA Center Kakinada, for his valuable support in this program organization. Thank you all. Thank you, sir.
Thank you. Bye all. Have a good weekend with family. Thank you. Bye.
Thank you, sir. Thank you.
Thank you.